Hello, everyone. Today we're going to start trig, and trig ratios allow us to find either angles that are missing using the ratio of side lengths given, or we can find side lengths knowing that ratio already exists if we have an angle. So it sounds kind of confusing, but for example here, in Pythagorean theorem, we need two side lengths. I don't have two side lengths, and it's not a special right triangle. So trig is going to allow us to use a reference angle, for example, this 61, and be able to set up a ratio that allows us to find missing side lengths. So in the world of right triangles, every ratio of sides has an angle that goes with it. So what's important in the right triangles is the reference angle. So for example, we're going to call one of the angles a reference angle. And our trig ratios are going to allow us, if we know that angle, we're going to call it theta, then given certain side lengths, we can find out what that angle is supposed to be. So for example, what we need to know though is there's three trig ratios. There's tangent, sine, that's sine, abbreviated SIN. Please don't call it sin. So it's tangent, sine, and cosine, abbreviated cos. Now, in the world of trig, we are going to study SOHCAHTOA. Okay, you need to know this. If you're not a mnemonic person, maybe you need to make one up, something like some old horse caught another horse tripping over ants. Okay, something funny, something you can think of. But SOHCAHTOA is your trig ratios. If I'm looking at the sine function, it's opposite side over h, which is always the hypotenuse. The cosine function is adjacent over the hypotenuse, and your trig function is opposite side over adjacent side. So sine and cosine are kind of like brother and sister because they always have the hypotenuse. Tangent is the only one that does not involve the hypotenuse. So let's look at what I'm kind of talking about to set up here. If I wanted to find the sine of A, that means angle A is my reference angle. So if I want to do the sine function, sine is opposite over hypotenuse. So from angle A, opposite is 15 and the hypotenuse is 17. That's all we really need. You would want to make sure that that is simplified. Your calculator is smart enough to know that in every right triangle, 15 over 17 produces a certain angle. Back in the day, they used to have charts that look like this. And if I took what 15 over 17 was as a decimal, so that's 0.8823, you would go to this chart, find 0.88 as close as you could go, somewhere around here, and then if it was the sine, you knew it was around 64 degrees. So I made sure I was under the sine column, 0.88. So it was here. So this angle has to be 64 degrees. So every angle in a right triangle has its own unique ratio, and every ratio produces an angle. So what we have to just be able to do is find the ratio. So if I'm looking at angle B now, so my theta, that's what we use for an angle instead of a variable, but you can use a variable. Angle B, since it's cosine, would be adjacent over hypotenuse. Now, adjacent means next to or touching. Obviously, the 15 and 17 are both touching, but we know 17 is the hypotenuse. So this would be 15 over 17. If we were going to do the chart, it would be 0.8823 again, but the point would be we would have to go under cosine this time. So 0.88 would be here, and the angle would be 28 degrees. Okay, so it knows that. And then your tangent of A, let's go back to A. So that's my reference, or this is my angle I'm looking at. Tangent is opposite side over adjacent. So opposite's 15, adjacent is 8, okay? Tangent, since sine and cosine are always over the hypotenuse, the ratio will always have to be a fraction less than 1 because the denominator will always be larger. Tangent, since it's side lengths and not hypotenuse, can get you a value, 1.875, larger than 1. If it was tangent of B, it would obviously be, so if I did the tangent of B, it would be 8 over 15, which would be less than 1. But tangent is the only one that can have a ratio larger than 1 because the other two, sine and cosine, are always over the hypotenuse, and the hypotenuse is the largest side. Okay, let's put this into how and why I'm going to use it. Okay, so let's look at our first example. I need to know this side length. I have this angle in the problem, and please note, in the right triangles, you can never use the right angle as your reference. It has to be one of the acute other angles. So in this one, I have this angle. So in order for you to figure out what trig ratio you have to figure out what is given from this angle. So from this angle, this is opposite and this is adjacent. How do I know? Because that's the hypotenuse, and the hypotenuse is not playing a role here. So out of my trig functions, which one does not use the hypotenuse is tangent. So now I know I'm going to use the tangent function. So it's tangent of 61. The angle always goes with the ratio, with the trig function, always. Angle has to be next to trig function. So now we know tangent. So here's something I'm going to cheat. So, TOA, I always want to have my ratios handy, so I don't have to keep going up. So tangent is tripping over ants, opposite 22 over x. Now, you can solve this any way you want. This is tangent of 61. We're going to use our calculators, is a number. So you can change it to a number now if you want. You can put it over 1 and do a cross multiplying. So I'm going to do tangent of 61 times x. Now, tangent of 61, if I use a calculator, I find the tangent button. And clear. Okay. Tangent of, hold on, the one thing I do have to do in all calculators, I have to make sure we are on degrees. So see that? I had to go to mode in my calculator and make sure we're in degrees. And we have to do that with all calculators, even Desmos Online and the little ones that we use in class. So now I can second quit. So if I hit tangent of 61 and hit enter, it is a number. The tangent of 61 is 1.804. But I'm not gonna try to do that yet. So what I'm gonna do is leave tangent of 61, okay? And so that I don't have to round in my problem. So x equals, I cross out, and now I'm gonna go to a calculator and just hit 22 divided by tan of 61. So now I don't have to round or anything else, and that'll give me the exact answer. 12 point, let's say 2, so 12.2. So our calculator knows what the tangent of 61 is. We're finding that if we have an angle of 61, using the ratio of side lengths, 22 over x, it had to be 12.2. Okay, let's look at another one. Okay, we're going to come here. The most important thing is your angle. That's what we call the reference angle. So this angle is the angle I have to use. From this angle, what do I have? So this is opposite. Hopefully you can pick that up. Adjacent means it has to touch it. So this would be the adjacent side, which is not involved. And this is the hypotenuse, which is x. So if I go to my trig functions, which one has O and H in it? So I look, no, no, yes. So it means the sine function, the angle always goes with it, not sin, sine. And then it's opposite over the hypotenuse. So it's 8 over x. Again, this looks very similar. X is in the denominator. Obviously, they could be switched. So I just put this over 1. I cross multiply. I get 8. Sine of 72 times x, multiplication. Do undo multiplication. I divide. And then I get 8 divided by the sine of 72. You're going to need a calculator. Any of them do it. We just have to make sure you're in the right mode. So 8 divided by sine of 72. Enter 8.4. Please make sure it makes sense. If this is the hypotenuse, it has to be larger, okay? So it has to be larger than the side. So perfect. Okay. See if you can try these two on your own. I'm going to stop after these two. So see if you can do them and see if you can come up with either the right trig function. Let's start there. What trig function would you use for this one? So pause the video, figure out what trig function, and start there. Hopefully you use this angle. Opposite, no, not important. Adjacent, because it's next to it, and obviously the hypotenuse. The hypotenuse should be obvious. Out of my trig functions, the one that has A and H is cosine. Angle always goes with it. Ratio is going to be adjacent over the hypotenuse, so it's x over 50. In this one, when I go to cross multiply, it's x, then it's cosine of 15 times 50. All you have to do is put that in a calculator. Just make sure if you hit cosine of 15, you close the parenthesis. Otherwise, watch, I will show you. Cosine of 15 times 50 is going to be much different. So make sure you close in there. So cosine of 15 times 50, and my answer is 48.3, I guess, if we're rounding. Okay, hopefully you got the last one video, but this would be tangent because there's no hypotenuse. The hypotenuse is not there, so it's opposite over adjacent, cross multiply, and that's tan of 33 times 12, enter 7.8 if we're rounding. Okay, that is how we will find side lengths given angles in trig. And the next thing we'll have to study is finding angles given the sides.